Yeah. So, Nikola, welcome to the show. This is the fourth episode of Pale Blue Nexus, and happy to have you on the show. We met prior to your big announcement last week, um, and it was quite a big announcement. Let me say something I knew something was coming when I saw some of your pull requests on the OpenClaw, and I was really excited about that. So tell me about your journey so far, and about yourself, and about the big raise.
Sure. Thanks for having me. It's a pleasure to be here. So, um, I I started DeepInfra about 4 years ago with two close friends of mine. We both met while working at a previous company for a long time together, and so uh, we really saw this need as these AI models were coming out. The interesting part about them is they're just a computer application, but they're like a computer program, but they're quite different. They require these large amounts of compute operations to produce even a single token. So the big models basically need hundreds of billions of multiplications to generate a single token or a single word out of them. And so we saw these models kind of just showing up slightly on the horizon. It was 2022. It was before ChatGPT, but you could see, for example, Stable Diffusion was this super popular open source models that can draw pictures. They had a lot of artifacts, as you remember, like people had a lot of fingers.
Yeah.
But it was kind of a demo of an open source model that's quite powerful and showing something that wasn't done before. And at the time, we didn't have ChatGPT, so you couldn't chat with the model, but you could essentially prompt the model to continue a sentence. For example, instead of asking like, what is the capital of Paris? You had to say the capital of Paris is, and let the model just continue the sentence. And even in that mode, you could still see kind of signs of intelligence in the model. So we wanted to use our experience from our previous, I guess, company where we worked. We built the infrastructure and the backend for a messaging app with over 200 million monthly active users. And so we had a lot of experience of how to procure and set up physical server infrastructure in data centers, and how to build like very efficient kind of backend APIs on top of it, and make sure we use like the infrastructure really fully. Like part of our secret sauce for the messenger was that we managed to get a very high utilization on all the hardware we bought by mixing different types of applications, compute hungry applications, memory hungry applications onto the same machines, and balancing the load until we get really high utilization of the infrastructure. And so I think the idea behind DeepInfra is somewhat similar. Like we building a cloud hosting platform for these AI models. Again, these are kind of like new applications, so they need somewhere to run. And running them is what's called inference. Yeah. I can go more into our journey, like from
Well,
very early parts,
it
but whatever.
sounds like the challenges that you solved at IMO.im are really sort of an input into the same problem that you're having with inference.
I think so. Like I think, life is kind of a journey. You see certain things that help you kind of navigate the next stage in a different way. And at IMO, one of the main takeaways was like how expensive AWS and the other public
Right.
clouds internet connectivity is, and how essentially more efficient you could be if you do it yourself. But it's not easy to do it yourself. That's why people opt up for the clouds, because
Mhm.
you get something done and ready. So you need to invest in it. You need the expertise to do it, but you can get to a lower like cost.
And talk about like the difference in cost between somebody choosing like a hyperscaler solution like Amazon or Azure against your solution.
Yeah. Um, I believe like we host a lot of different open source models and each of them has its own price. So it's really not that easy to compare one to one. But if you look at the GPU pricing, we are offering B200s at 275, and I believe like the public clouds pricing are in the 6 to 10
Okay.
plus range. And you typically, to get that numbers, you have to do like longer term commitments as well and commit to that cloud. Um, and then on the tokens, there's another layer of efficiency, right? Like we believe we have really efficient systems that can generate more tokens an hour per card. And so that's why we can offer better pricing per token and also cash token pricing that's really, really attractive. That's sometimes 10 times cheaper than other options or closed source models. In some way, I think the big clouds have really focused more on like hosting Anthropic and OpenAI models or Gemini. So the real comparison here is like how much does, I guess, Anthropic's model cost at AWS versus how much does DeepSeek cost with us. It's not the same model. DeepSeek is still slightly worse, like 3 to 5% in some benchmarks, but it could be like 10 times cheaper.
Okay. So cheaper is one thing. The one thing I did notice though, I sort of use your back end because I use Llama and you guys
Yep.
help them provide their services. I noticed over the weekend it got a lot faster. Like I would type something in and my bot is responding like right away versus there being some maybe 2-3 seconds in between when it I don't know what happened there, but keep up the good work.
I can share something. We basically over the weekend, like a big batch of our infrastructure, new B300 GPUs came online. And so there was a lot more breathing room for all the models to scale up and go faster. I hope it's that, but we never
Whatever
know.
you did worked. It's responding quite faster for me. So I can't wait to get out there and use it. I feel like that was a meaningful upgrade from a user experience perspective. So
Thank you.
so let's talk about scaling to, I guess your app scaled to 200 million monthly active users, and this sort of inference level, how much customers are you serving right now at DeepInfra, and how much tokens are you delivering?
So DeepInfra, we're doing over 5 trillion tokens a week across like
Jeez.
all the models that we serve. We also do some, cluster rentals to new labs and other customers. That's kind of in addition to the inference business. It's been an interesting journey, like over the last basically 4 years. The growth really started once Llama 2 came out. And that was like the first commercially allowed open source model that was decent. Like for its time, it was like the best open source model. It was quite large. 70 billion parameters is a, was a big number at the time. And so from that moment on, we just started seeing growth in tokens, and it was always growing exponentially. But we started from a very small kind of base. And so then it was kind of like a wave of new models coming out and us raising more capital and investing in more infrastructure. So for the Llama 2, we only had, I think, a couple H100 GPUs. Mostly it was A100. And then we got our seed round. We got a bunch of H100s with that. and we could serve the Llama well. And then Mistral came. It was like a small 7B model. And actually, one of the biggest changes for us was when Mixtral came. This was like the first mixture of expert open source model. So it's kind of like a new generation thing. And the story there was I'll go a little technical. So this model was basically 8 7B models together. The
Okay.
experts were 7 billion parameters. And during runtime, you would use 2 of the experts. So the model should be as expensive as 14 billion parameter model to run. But as soon as that model shipped, everybody in the market priced the model as if it's like 50, 60 billion parameter model, like using the full number of weights. And we were really aggressive. Like to us, it was quite clear that this should cost as much as like a 14 billion parameter model, because that's what you would use during
Runtime. Yeah.
runtime. And so we just priced this model really aggressively. I remember, we announced 27 cents per million tokens. And at the time, other people were at $60, 60 cents. And
Wow.
so that got a lot of attention on Twitter and a lot of traffic for our model. I think around that time, people started saying, "Oh, Inference is race to the bottom. Look at, the prices of these things going down." The interesting thing is that even though this price was really aggressive for day one, because when the model comes up day one, it's not really efficient. It really, over the next month or two, like the efficiency of how well we run this model really improved dramatically. And, this model ran for like at least a year or maybe 18 months before we kind of deprecated it. I think the price went even lower, like after that. Like we just had more and more efficiency, and we could serve it for considerably less. I think the software got better on our side, and so we could offer lower prices to our customers.
What's the main factor there? Is it the quantization or is it the inference sort of routing and engine?
It's a good question. Actually, there's like a bunch of things. So
You don't have
one,
to say your secret sauce.
well, I'm gonna like mention like few of the main techniques that I think make these models more efficient. That I'm happy to share. So quantization is obviously one, and interestingly, like the newer generations of NVIDIA GPUs basically support lower and lower precision math. We believe that, and NVIDIA also strongly believes this because they're dedicating large portions of the chip to this like low precision compute. They're mostly investing in this 4-bit types, the
Okay.
FP4, NV FP4. So one thing is quantization of the model, which to some of your listeners just means like you're compressing the model down. Like instead of using 16 bits per parameter, you use like 8 or even 4. And that really helps like make the model smaller. You can both do more math, the smaller the precision is, but you can also fit the model into like fewer cards or leave more space for KV caching. Now, KV caching is the other really kind of important optimization. In these agentic workloads, what the model really does is it basically sends roughly the same request many, many times with like a little bit additional information at the end. So if you can save some computation from the last time you did the inference, then the next time you have to do inference for the same kind of customer, you can be really efficient. Like you don't have to bother the GPUs with the big portion of the request. And that's kind of a big efficiency gain. So we were one of the first people to have cache token pricing on Open Router
Okay.
and offer it to like our customers, obviously, as well. And that's a big part of it. And then there's a bunch of other techniques, and it's kind of all layered together, and also more efficient kernels, like moving to more efficient GPUs. Um,
This sounds more like fine-tuning a Ferrari than it does racing to the bottom, like type of thing, right? But is a bit of both.
yeah. My analogy is I think it's a lot like Formula One, and I'm a big fan of Formula One. The the teams there are always obsessed with like reducing the weight of the car and then squeezing some more power from the engine and squeezing some more aerodynamic efficiency. So like at the end of the day, you have to pursue like all avenues of making this more efficient to kind of end up winning or
Right.
being the top few people.
Yeah. And you guys were took capital from NVIDIA. Tell me about like what they're doing with NVIDIA Dynamo. Is that part of your stack now, or is it going to be? And how to and we'll get into the open source versus closed stuff later. But tell me about NVIDIA Dynamo right now.
NVIDIA Dynamo is like an open source project started by NVIDIA that is really like, I think, the next level of efficiency in terms of inference and scale.
Okay.
So I think internally at DeepInfra, we've implemented large portions of the ideas behind this already, and we're working more and more closely with the NVIDIA team on this project as well. For some of your viewers, it's basically something like on kind of like Kubernetes in terms of
Right.
it helps organize how the inference happens. Because inference is to get the ultimate efficiency, you need to run this kind of at a big scale. And Dynamo kind of helps organize the scale around this and disaggregates like one portion of the work with another portion of the work. So I think it's an important project. And I think NVIDIA is developing it really well with essentially supporting various different inference engines underneath, like VLLM and SGLang, in addition to the homegrown TensorTLM from NVIDIA. I think also the project supports also non-NVIDIA hardware, which is, I think, the right approach to make this the real fundamental system for inference. So we're generally excited to collaborate with NVIDIA on this front. And the relationship with NVIDIA started more on the technical side. Like we see a lot of tokens going through DeepInfra, and we see a lot of tokens flowing through like various generations of NVIDIA GPUs. We were really early adopters of Blackwell
All right.
type GPUs. And so whenever we see any instabilities, any crashes, any performance issues, we would share these with the NVIDIA technical teams. And on their side, the NVIDIA technical teams would help kind of address and fix and improve, I guess, the libraries that we use for inference. And so it was a good loop. Like, we would share like important information that helps kind of make decisions on their end of like what models to support and what models to make more efficient and what models to fix like stability issues. And because
Okay.
we have a lot of traffic, we see all these random, I guess, events that cause like weird crashes that are really hard for someone who doesn't have the same amount of traffic going through their system to notice and fix and improve. So we're just pretty open and shared a lot with the team. And I think I want to speak a little bit for them, but like for NVIDIA, it's really important to have really efficient software for inference, right? Like at the end of the day, like their customer measure whether to buy their hardware versus someone else's hardware on like how many tokens can this thing generate for me in an hour? And does it have like support for many different models that I might want to use? And so I think they're coming to this with the right mind. They understand that they can't just like sell the GPUs and that's it. They
Mm-hmm.
need to invest a lot of engineers to work on the software layers of the stack to make the GPUs really useful to someone, not just us, like just any of their customers, right? So I think they understand this well, so they've invested a lot of effort into the software side of their cards to basically show like the highest inference performance compared to other hardware.
And I mean, this reminds me of a few different parallels within the tech world in the last 20 years. One of it being like the latency aspect. The other part is the open source aspect, like Red Hat. But going back to latency, um, you remember how high frequency trading used to happen closer to New York, where the data centers were to the exchanges. Are you experiencing similar build out challenges where people want higher, lower latency, so they want to be closer to their cloud or to their infrastructure?
It, both kind of yes and no. I feel like the answer for inference is more complicated. Like, let's take a typical request, right? Like, imagine you asking ChatGPT to do something and passing like a big document together, like with your initial prompt. So the model needs to do this initial step of like look through all the data you've given it before it starts giving you the first token. That's what's called the pre-fill phase. And so that might take like from 100 to 200 milliseconds all the way to like seconds, depending on how much data you've given it. And then the model starts giving you tokens, and then like it might take 5-6 seconds for the whole thing to complete, right? Like the model starts giving you text. And so actually there's a lot of latency built into the whole inference. Like from end to end, the requests take like long time, like on the order of 5 seconds to 10 to 30. And so we've noticed that we don't believe like trying to put the actual compute like right next to the humans is the most efficient way. Like to get lower latency, I think we just have to build like the right orchestration of GPUs and host the model in a way where we could generate the tokens well and do the caching well. And the other thing is like, I think if you look at high frequency trading, they need like the very latest data from the exchange, and they need to run like something really quick and like make back like a request to buy or sell. And all these things are super small, and they don't need to run a super complicated algorithm to decide like which of these two ways to do it. So they don't need a lot of power is what I'm trying to say. But inference is really, really power hungry and compute hungry. That is why like, there's all these data center projects in the US, and most of them happen in like rural areas, not near the city. Just the price of electricity and like the economics of deploying the GPUs work best in like more rural areas. So what latency is a big portion of it. I don't think the solution is mostly the solution is not let's move the GPUs next to like the population centers. There will be some sort of GPUs nearby for like very low latency tasks like voice tasks, or maybe even robotics tasks. Like there will be some things that would require ultra low latency. But I think the AI engineer, software engineer, the AI doctor, the AI teacher, potentially, the latency would be okay for these things to be hosted from just the AI factory in the middle of the country. Now, I think you had another question about the open source model, so I'm happy to dive into that. Like this is a big theme.
Yeah, I mean, open source, I am a big Unix fan. I started my career being a Unix administrator. And I've just seen how it's been proliferated throughout the years, with Red Hat going to enterprise. Um, and different flavors of Unix. Even my Mac is running on a flavor of Unix right now. So, talk to me about open source and how that's a strategic sort of like bet for you guys.
Yeah, I want to give you like a little history of myself too. So I'm also a very big user and proponent of this since I grew up. Like one of my teachers in high school that taught me how to program, he was a really big proponent of Linux and Unix. So like I've used Ubuntu since the basically 2004, and ever since I've always like had Ubuntu like as my operating system at home. And even I want to tell you a story on the phone side. Like whenever like iPhone came out, right? Like Google Android operating system was supposed to be really open source and open. So I'm still sticking with Android since like
Mm-hmm.
the beginning. Although I have to say, like it didn't turn out as I hoped it would. I feel like sometimes I don't know, Android doesn't feel as open source as it should. But on the topic of open source versus closed source models, it's kind of a really serious discussion that I think when we started the company, DeepInfra in 2022, that was the biggest risk to us. Like I knew that there would be a lot of demand for inference. I just didn't know if there would be open source models. And it's a tough job because you have to invest like considerable amount of compute resources to build a model. And then you make it open. And so like not that many people can do this. Like it requires support from big organizations. But any open source thing has like all this community innovation that happens around it. And so and the innovation feeds off of each other. So like Facebook made Llama or Meta made the Llama models. And then, Mistral did the first like mixture of expert ones. Then DeepSeek really took this to the next level and did a lot of small experts and added like some interesting attention things like the MLA. And so like then a bunch of other people basically managed to train DeepSeek like models like Kimi and GLM and so like I think the cool ideas get adopted and some more compute resources get invested into it. So I feel like AI is really important. It's good for us to have decent, even if they're not the top open source models. It's still, I think, a good option for enterprises and just researchers and universities and all of us as a humanity to have a good layer of decent open source models we could build on top of. Over the last 3 years as I've been watching this develop, I believe like the closed source models have improved dramatically, but the open source models have really kind of caught up to them. Like when Llama 2 was out and OpenAI had their, I think GPT 3.5 or 4 at the time, the gap was really big, like, almost half the intelligence or something like that based on like benchmarks. But now, if you look at how well they stack, still the top models in terms of intelligence are the top 3 closed source lines of models. But basically, the next right after that are open source models. I wish we get more US based open source models, and I think that's coming thanks to NVIDIA in some sense for doing Nemotron line of open source models, but also we believe like a lot of other labs in the US will also release open source versions of models as well. So,
I
yeah.
my stack is like I was using the frontier models, the US frontier models, and then I just found one day with Kimi 2.6, it was like I can't see the difference anymore. It's almost it's not 100%, but it's caught up quite a bit. And with DeepSeek 4 Pro and Flash, it's the edge is going pretty fast. So I think like for me and maybe a lot other devs out there that are looking at this stuff, it's coming closer and closer. So we can see, what happens 6 months from now, right? So uh, there's that as well.
I agree. And I think another thing I want to point out here is even for a moment, as a mental exercise, imagine we freeze all the models right now. No one makes any models any better. The exciting part is like we've gotten to a level that is really useful. Like even expert software engineers, and I like to think like I'm one of them, are mostly not writing any code anymore. Like they're using these agents, coding agents, and these frontier style models, both open and closed, to produce much more kind of software than they could otherwise by doing it by hand. And so it's
Hmm.
kind of like as if we've invented the compilers. And from now on, we'll just write high level code and compile down to like the machine instructions. I feel like the AI models are kind of like a compiler for us. Like we give high level instructions and the thing lowers it down to code that then gets lowered by the compiler to the actual machine instructions.
Yeah, you're right. Like this spec-driven development type of idea where you can just give it a spec and ask maybe the frontier model to come up with a spec. Then you can take that spec and give it to a good enough model, and it would, as long as it has some guardrails, it'll go and code it for you. So
Yeah. Exciting times we live in.
yeah, yeah, you could really boot up a lot these days. Talk to me about like the next level of security and compliance as these sort of solutions get rolled out to bigger companies and enterprises and bigger businesses. Like right now you guys are SOC 2 compliant and ISO 27001. Um, how are you seeing any pushback from bigger enterprises? Are you looking to go to the next level on that regulation front?
Um, on the compliance side, there's we first we always like our posture in general in terms of us owning and operating the actual underlying kind of infrastructure and having like almost no like sub-processors underneath us, only in like very rare cases. So most of the tokens that we generate happen on our own hardware in our kind of own spaces. And I think that's kind of what enterprises should be looking for. Just to understand, you need to understand well the chain of who is going to handle your request down to the actual execution. You want to make sure you're not like giving it to someone that will give it to someone that will give it to someone, and maybe the final inference happens in China, right? And so I think companies need to be careful about like who does the inference where and like whether they trust this company. So as a startup, it's a journey, right? Like we can't convince day one like some super large enterprises to
Yeah.
like trust us with their data, but we're definitely far along on this journey, and we have like large enterprise customers using our infrastructure. Now, I actually see this as an important thing. Like even though the models are some of them are trained outside of the US, we're kind of like the safe environment where we run them on our US based
Right.
B300 NVIDIA GPUs, and we have zero retention policy, so we don't store any data. Um, Kind of like this zero retention thing because you don't have to spend anything on storage, and your customers feel safe, and you have this less exposure, less risk of stuff leaking out of your infrastructure. So I think the security, by the way, of these models is going to be like probably the biggest thing we will be thinking about in the future. I think it's not as much about like it's not in the traditional sense of like are my data center secure, is my system secure. It's like a little bit about the model itself. And there's a lot more verification that we will need to do to make sure the model wouldn't make a mistake that might be costly or cannot, all these prompt injections are basically us kind of tricking the model into doing the thing that it shouldn't be doing. So there's a lot. I think we're not really safe there on many fronts still, even the frontier models. Like I'll give you a small example. Like I think we're still not safe in the way where you can just say OpenClaw, here, read all my email. Because I feel like the right scammer would basically send the right email that will prompt inject the model potentially to share like information and take over. So some of these things we need to be careful with. But on the other hand, it's kind of, you cannot be too slow in adopting this technology because then your business gets kind of left behind or your competitors are taking the full advantage of it. So we need to balance the adoption. I think at the moment there's like definitely risk, but I think the rewards are still higher. And so you have to take some of the risks, just have to minimize the risk as much as you can.
Tell me about like NemoClaw. Like I'm very interested in this topic. It sounds to me like there's obviously like a wrapper on top to help make
Yeah.
OpenClaw more enterprise friendly. So I kind of see where
Yeah.
that's going.
So I want to explain to like the viewers about how I think these two things work out. Like you can either have there's two ways to build these things. You can either start with a system that's really open and is allowed to do everything, and then just see what are the bad things it could do and try to like prevent some of them. And I think that's more of a open claw. Like by default, the thing is really open. It can like do many things. While NemoClaw is NVIDIA's kind of attempt at starting in the other way, like start with something really secure. Like by default, the model is not really allowed to like access the internet or do many things or execute anything. You have to explicitly allow what the model can execute and access, and basically that way you can start from this end. Like we start with something really secure, see what it actually needs, only allow the minimum set of things it needs to really execute. And that, I think, makes sense for obviously enterprise adoption. So I think there's active development there. We'll see where this goes, but we're looking, more and more in kind of ways to encapsulate and secure these agents, give them enough freedom so they can execute, but also make sure that they don't have unrestricted access. And then also, I think more and more there will be work that essentially monitors the work of the agent and looks for essentially suspicious activity that might happen, and then you can secure the agent in that way as well.
Okay, that's interesting. So that's the where NemoClaw comes in. It's
Yeah.
like a trusted sort of OpenClaw in a way.
Yeah, it's basically OpenClaw inside like for lack of better words, like a jail or a shell. And so before it can do anything, it has to ask.
Okay.
Well, you can see what it's trying to do, and then you can decide to approve some of these actions and build this more contained environment for it.
Okay. Let's talk about the ICP for DeepInfra. Like, are you guys expanding into the more regulated space, the I guess the enterprise space, or are you happy being in that small to medium business startups, tech startups area where your cost savings are much needed?
The way I look at it is I feel the demand for tokens is really high and it's coming from everywhere. And we don't have it's kind of in stages. we really want to help the people that need a lot of tokens at scale. And at the moment, I feel it's not really the large enterprises. They're still figuring out how to use it and where to use
Hmm.
it. It's the people who really need tokens at scale are like kind of AI first companies that are building a product that it's like AI powered from the bottom up, not
Right.
how do we insert some AI features into our existing SaaS, which still is quite powerful use case. So we try not to lock ourselves in any segment. One thing I can say is probably we're not a best fit for like the super regulated people, like banks and
Hmm.
other folks are really interested in doing this like in an extra secure way on premise. And that's, our inference cloud is not the best fit at the moment for this use cases. Uh, so yeah, we just try to scale our platform, add more compute resources to it, add more models, and then we have a very light outbound motion at the moment. Mostly all of our clients are kind of inbound. And so we look to help the people that need tokens the most.
Okay. Tell me about like how you've been handling these last few weeks personally in your life. It must have been quite a whirlwind over the last month or two. How are things going, and how are you balancing that? Are you going to the beach or having some fun?
It's really tough. I think one thing I can prepare your viewers for, like if you want to be a founder, you're, doing it because you're hoping that the company is successful. But when the company is successful, then the amount of work for you really grows a lot. And you kind of have to, your job is a little bit of more building the company than building the actual product. Like you have to go and find the right people and
Hmm.
hand them off each like particular area and trust them. And so there's a crazy amount of work right now that leaves no slot empty on the calendar and no time to cover everything. And you have to just try to think every day about like what are the most important things for us today and this week and prioritize those versus like the incoming like wave of tasks and other things
Hmm.
that are coming to you, and just move forward. um,
What kind of culture
really-
are you going to bring to DeepInfra internally?
so I'm really happy that I got to recruit a lot of my old team from IMO Messenger, where I worked together with some of these folks for many years.
Hmm.
So we already had like a lot of work together and culture together, and so you I don't like scaling the company too quickly because I want to make sure like the new people get to learn from the existing people about like what we think is the right way to think about problems and approach them. And I don't think some companies grow too quickly and then there's not enough scope for the individual people to do, or they're working on things that are not really high priority. I think it's better to be a little bit understaffed
Hmm.
than overstaffed. I mean, culture is pretty important. We're very light. I don't think we have any managers really at the moment. So that's expected from a small company.
Cool. And so what are you looking forward for the rest of 2026? Like how do you what's exciting to you?
I think I'm excited about scaling the compute clusters. So there's like a crazy build schedule over the next few months, and I think it's going to get even crazier towards the end of the year. I guess bringing these clusters up that we've already kind of in the middle of their production. Just to give you an idea, by the way, like setting some of these compute clusters is like, I think, a major construction project. Like, they cost like tens of millions of dollars, and there's a lot of physical setup for them. Electricity wires, like it's kind of almost like building a house. They need like containment walls and then cabling. So that's exciting. I think I'm excited to scale the company. Like we are actively hiring for a number of different positions and interviewing. And so getting the right, really motivated, experienced, but also hungry people to the right positions and giving them a chance to just like contribute is really important. I remember like in our journey, like we had quite a few kind of key hires. Like we couldn't have gotten here without getting this person to join us right at this moment. And they really took a big burden out of what I was doing before, and they kind of operate well. So like that's scaling the team is an important part. I think our business is really capital intensive.
Mm-hmm.
So for us to be successful, we need to be good at raising funding, both equity and debt.
Mm-hmm.
That is an important vehicle to finance these clusters and this infrastructure, and you have to, I guess, do a decent amount of it, and you have to do it really well to get to like better cost per capital, cost per token as well. So exciting times.
Just a random question: Are the servers, the hardware that you buy, are they do they have some level of depreciation over time?
Yeah, this is actually one of the biggest stories behind this whole boom of AI. The biggest kind of underlying question is how long would these things that we spend money on setting up like essentially last us? And I want to give you like my perspective from my history with first the Messenger, right? So I joined like the Messenger in 2010 when we only had about 100 servers there. And then I ended up growing that number of servers to like 2 to 3,000. At the time, a lot of people were saying, okay, every 3 years, we're going to basically throw away the old servers and buy new servers. But for the Messenger, while I was doing this to, set up our infrastructure, I kind of always thought, okay, 3 years have passed, the server is still running. It still has memory and CPUs. Why throw it away, right? Like, I guess when you do the math, the price of buying the new server, and the new server is basically for roughly back then, like the price of servers would almost not change. So the servers would always be like around $5,000 each. These were really not the NVIDIA servers that we have today that are like crazy expensive, but the servers will be roughly 5,000. And throughout the 10 years I was there, like that price didn't really change up or down. It stayed around this number. But what you got every year is like some better CPUs and some faster memory in each server. So anyway, my long story here is like at IMO, we ended up not throwing away any machines.
Nice.
And we kept them for 5 years and 7 years. We would just move them a little bit from like high priority applications to low priority applications. So when the machines got older, I would just, for example, use them in our Hadoop clusters to do data analytics.
Right.
Because a failure of a machine there would basically have no effect, while failure of a machine serving live customer traffic is kind of more important. And so I think we did a really good job there of using the infrastructure really efficiently. And we were really scrappy. And so the big question here is like, how long would the servers that we buy now be useful for? And yes, NVIDIA comes up with better and better GPUs all the time. But what we've seen is that even the oldest servers we have, the A100s or the H100s that are now like 2.5 years old, are still pretty fully used. And even the prices that we would charge for them has gone higher.
Interesting.
Mostly the function of the demand.
Hmm.
Um, I feel like we will keep using this infrastructure. We'll build new ones, but there's so much demand coming down the line that even the oldest ones would still be pretty used.
Okay. Um, you have a pretty good perspective of this. So, what is the most overrated thing in AI infrastructure right now, you think? And where's, in a few years, we'll be like, what the heck?
It's a good question. I think like right now we're not asking ourselves like often the questions like, do I really need all of this? And what part of this do I really need? And so I try to keep asking this question all the time, like, this thing that we bought, are we using it, and how used it is it? And so at the moment, I'll tell you like what I think, and I might get a little bit in trouble. Like NVIDIA has generated this reference designs of like how to build a cluster using their GPUs and their networking switches and all in between. And this has been important for training. I think the designs are mostly following like what do you really need to do efficient training. But I feel like inference is quite different, so it just requires a different design, and there are different questions. Do we need these parts? What are we going to interconnect them? How do we build a network that is good for inference? And so that's the part where I think like we could optimize more the infrastructure. Yeah, and the other part is maybe storage. Like people seem to, I guess, buy a certain amount of storage and pay like quite a bit of premium for like these fancy storage providers where I don't know that you really, how much do you really need that? Depending on what you're building. What I like to do is you set up something and then you have to look at it and see like, okay, I'm using the GPUs at this level. Am I using the memory? How much of the memory I'm actually using? So
Hmm.
not too many people can give you like just a number. Out of all the memory we've bought, how much is free right now and how much is used? Like
Hmm.
this is like an important number, right? When you buy your next machines, if you're having so much free memory, then you should be buying a little less memory per machine. And the same questions for the CPUs, like how much of your CPUs are you actually currently utilizing? Like what percent of the cores are idle versus busy? And the same thing for the switches and the other things. And this is what we did a lot at the Messenger. Like we basically tracked graphs of, there was 4 key resources like memory, CPU, disks, and networking. And so we would have graphs data center wide of like how far are we utilizing each of these. And then it will impact our next purchases so
Hmm.
that we kind of made sure that the mix is right.
Okay. Nikola, I just wanted to say thank you so much for these answers. They are going to um, help my audience get even more interested about AI and sort of the hardware and the infrastructure that goes behind all of the cool little requests that we talk to all of our AIs every day. So thanks for that, and we appreciate you coming on.
Thank you so much. Pleasure.